Good afternoon, everybody. Still afternoon, not evening, isn't it? It's 3:30 only. 3:40 only, or 3:41. All right. So, in today's class, students are going to solve the questions given in their exercise. Chapter is Force and Motion. Multiple choice questions. How many multiple choice questions are here? Altogether? 11. 11 multiple choice questions. Distinguish between 5 short question answers. 10. No, 10. Here 10, 11, 12, 13, 14, 15, 16, 17 are there. Long question answers. 9. Give reasons. 7. 8. Reasons 8. And give reasons and not 8 also. Up to Q means 10, 11, 12, 13, 14, 15, 16. 11, 12, 13, 14, 15, 16, 17. And diagrammatic questions will be discussed later. Okay. Without wasting time, let's call on the stage the person who is going to present today. The first person is Biyan. And who is the super guru? Simres. Okay, Simres is super guru. All right. If super guru is not needed for this minor one, we can skip and do next one. Okay, come on. So let's go on quickly.
Namaskar everyone. Now, without wasting time, I like to start my topic. Unit 7, Force and Motion. Define gravitation. Movement or tendency to move towards a center of a gravity, as in falling of a body to the earth, is known as gravitation. And the SI unit of gravitation. The SI unit of a gravitation is Newton, and states Newton's universal law of gravitation. Newton's universal law of gravitation states that every particle in the universe attracts each other particles with the force along joining them. The force is directly proportional to the product for the masses and inversely proportional to the square of the distance between them. And what happened to the gravitational force between two bodies if the distance between them is half, while keeping them masses constant? If the distance between the two bodies is half, then the gravitational force between them is 4 times than the original. And what will be the gravitational force between heavenly bodies if the mass of both are triplet, keeping the distance between them constant? If both mass are triplet, the force of gravity is multiple by 9. And what will be the gravitational force between two bodies if the mass of each other them is double? When the mass of both objects are double, then the force between them is 4 times. And you can say that. Define G and with its value. The universal gravitation constant is the gravitational force acting between two bodies of a unit mass kept at a unit distance from each other, and its value is 6.67 into 10 to the power minus 9 Newton meter square per kg square. And what effect would compressing the earth to the size of a moon have on the acceleration due to gravity? The acceleration due to gravity of the earth would be increased by about 14 times then of the present value of its surface if it is compressed to the size of a moon. Thank you and have a great day.
Thank you very much. So, in my opinion, so for minor things, let's not solve the super gurus. Okay. Super Guru, they will just explain how we measure one. All questions he has done well. So one question I just want to remind here. Define gravitation. Gravitation, what have we defined? The mutual force of attraction between two masses in the universe, right? The mutual force of attraction between two masses in the universe is gravitation. That is one. Others are okay. And the last one I want to make concept clear here. What is the question? What effect would compressing the Earth to the size of a moon have on the acceleration due to gravity? So here remember, what is the value of acceleration due to gravity on the Earth? G equals to 9.8 meter per second square. Hey, remember. Okay. When we compare moon, what is radius? Radius of the moon is 4 times less than that of the Earth. So 1 by 4 of R. Is it smaller, shorter, right? So if Earth is squeezed to moon, means mass remains same. So G nu will be capital G, capital M by Rm whole square, right? So Gm by Rm whole square means Rm is how much? 1 by 4 R whole square, right? Then how much does it come? Gm by 1 by 4 means 1 by 16 R square, right? Gm 1 by 16 R square. Then this 16 goes up. 16 Gm by R square. But Gm by R square, its value is there. How much? 16 times 9.8 meter per second square. How much does it come? 16 multiplied by 9.8 meter per second square. Or it increases how many times? Near about 16 times. Near about 16 times. He has got given here how many times? 14 times. This is also okay. Or if you write 16 times also, that is okay because it is increasing, isn't it? Okay. That is all about first presentator's duty. Now let's welcome on the stage the second presentator. Who is the second presentator? Bibeki, and we'll check whether super glue is needed or not, right? Please come. Oh, they have seen nearly at the same time, right?
Namaskar and good afternoon, everyone. It's me, Bibeki, and today I'm going to solve short question answers. The acceleration due to gravity on the Jupiter is 25 meter per second square. What does it mean? The acceleration due to gravity on Jupiter is 25 meter per second square. It means that when a body is dropped from a certain height on Moon, then velocity of
On Moon or on Jupiter? On Jupiter, right? On Jupiter.
then velocity of body changes at the rate of 25 meter per second
In every second. That is okay, right? Give a big round of applause now. We'll check one by one, right? Number 2.
in a vacuum. If a coin and a feather are dropped, which one will reach the ground first? Why? In a vacuum, if a coin and a feather are dropped, then coin will reach the ground first because of acceleration due to gravity is independent of the mass of the falling body.
And this is wrong, right? So what is the question? In a vacuum. Vacuum means in vacuum all bodies they fall together. We have studied that acceleration due to gravity is independent to the mass in mass of falling bodies. So here vacuum means there is no any resistance. If no resistance, then both coin and feather reach on the ground together at the same time. Okay, you have to correct. Both the coin and the feather will reach at the ground or on the ground together because there is no any resistance. Vacuum means there is no any medium. That condition where there is no any medium is called, what is it called? Vacuum. Hey, so remember. Next one, that's how we'll check also.
Where does a body have more weight, at the pole or at the equator of the earth? A body have more weight at the equator of the earth.
A body has more weight at the equator. You're also wrong. A body has more weight at the poles. Why? At poles, the radius is short, value of acceleration due to gravity is more. We have just mentioned. Like we discussed, no? What have we discussed? G at equator is 9.78 meter per second square, and G at poles is how much? 9.83 meter per second square. If so, we know W is directly proportional to G. More acceleration due to gravity, more weight. So acceleration due to gravity is more at the poles, weight is also more. Okay, you correct it. All right. So sometimes we do mistake, no problem. So we just correct and learn.
An astronaut is considered weightless when traveling in a satellite. Does this mean that the Earth does not attract him or her? Yes, it means that Earth does not attract him or her.
Yeah, okay, that's right. Weightless means not attracting, isn't it?
Does define free fall and explain what happens to the weight of a body when it is falling freely under the action of gravity. When a body falls freely towards the center of the earth under the influence of the gravity, the motion of body is called free fall.
Okay.
When the body is falling freely, it is acted upon by the force of gravity, but the object is not applying its force to any surface, so the weight of the body is zero.
The weight of the body is zero. And next thing we have to keep in mind why the weight of the body, weight of the freely falling body is zero. So what happens? And there are two conditions. One thing you have to remember: the Earth pulls it with acceleration due to gravity. It has got, and it also contains acceleration, and their acceleration will be how much? Equal. G and GA will be equal. So when we subtract G minus A, how much will you get? Zero. Okay. Acceleration due to gravity, and it's also falling the acceleration. The difference is zero. Weight also will be zero. All right. Next.
What is the effect of gravity on a falling object? The effect of gravity on a falling object is it has more acceleration.
It has more acceleration. And the effect of gravity on falling object is the body is pulled towards the center of heavenly body. What do you mention there? The body is pulled towards the center of heavenly body. Okay?
Write the difference between the fall of parachute on Earth and its fall on the Moon. The fall of parachute on Earth is it has more acceleration, and on the Moon is it has less acceleration.
Okay, the fall of parachute on Earth is more acceleration, and it has. Here we have to say, fall of parachute on the Earth is not free fall because there is air resistance. He doesn't look at here. You are just pinching your nose and looking outside. What do you want to do? Collect some of oxygen or what? Huh? Fall of parachute on the earth is not free fall because there is air resistance. And fall of parachute on earth is free fall. On moon is for free fall. Fall of parachute on moon is free fall because there is no air resistance. So the parachute does not fall with the acceleration equal to acceleration due to gravity on Earth, but the parachute falls with acceleration equal to acceleration due to gravity on moon. Okay, that is the difference. One is free fall, another is not free fall. Why? Now your food is already finished.
On what condition does a body experience free fall? A body experiences free fall when an object falls towards the center of the earth due to gravity.
Yeah, a body experiences free fall when an object falls toward the center of the heavenly body due to gravity, where there is absence of air resistance. In absence of air resistance, only people can be experienced. Suppose if somebody jumps down from up, then that is also not free fall because there is air, and air blocks or decreases the acceleration of that body. Okay, next.
Provide one example of weightlessness: stone hanged on a spring balance at rest.
Stone hanged on a spring balance at rest is weightlessness. What is weightlessness? Weightlessness is the condition at which weight of the body is zero. So, when we take one spring balance and hang a stone, or we can say the spring balance containing a stone does not show any value because of weightlessness. Or if a body is falling freely, then there is weightlessness. I mean, so the let's take 20 kg mass on the moon at a certain height and drop it. Right? When it is dropped, then what will happen? It just falls freely. At that time, its weight will be how much? Zero. So the weight of freely falling body is zero. We have to remember. Or the weight of the persons who are inside the artificial satellite, that is also zero. There is weightlessness. There is no air resistance. That's why weight seems zero. Okay. Simply, we can say weight of the falling body is freely falling body is example of weightlessness.
Thank you.
Thank you. Okay. So yesterday I think they have already done. What have they done yesterday? They have done MCQ. Today, short questions are also discussed. Because last time I was just saying, okay, if there is some extra thing, the super guru will come and explain. Otherwise, like that only. Okay. Now, next presentator is Poojana Shrestha. Are you ready? Why the already mic is ready. Okay, very smart. Okay, what is he going to explain? Let's check. How many slides has he brought? 11 slides. Okay. Sorry? Only you three or no? No, they have just made a bit bigger one. I think these are long questions, right?
State Newton's universal law of gravitation. Elaborate on the relationship between gravitation and the distance between the center of the body. Newton's universal law of gravitation states that every particle in the universe attracts every other particle with a force along a line joining them. The relationship between gravitation and the distance between the centers of the body is gravitational force is inversely proportional to the square of the separation distance between the two interacting objects. More separation distance will result in bigger.
Finish?
What will be the gravitational force between two heavenly bodies if the mass of both are triple here? L is missing. Keeping the distance between them constant, elaborate on the relationship with equation and diagram. The gravitational force between two bodies will increase by a factor of 9 when their masses are tripled while keeping the distance between them constant. If the both masses are tripled, the force of gravity is multiplied by 9. So here is the equation. F is equals to g times m1 into m2
It'll come.
by d square. So according to the statement, the mass of the both body is tripled. That is, m1 is tripled 3m1 and m2 is tripled 3m2, keeping the distance constant.
It is coming. Yeah, okay.
F1 is equals to g times 3m1 into 3m2 by d square. F1 is equals to 9g m1 into m2 by d square. From equation 1 and 2, F1 is equals to 9f. Hence, the force of gravitation between two bodies will be increased by 4 times if the mass of the body is tripled. Thus the gravitational force between a product of their masses, that is F times m1 into m2.
What is he saying? So what did he say? So if the distance, no, if the mass of each body is triple means what happened? M1 became 3m1, M2 became 3m2. Distance is same, means 3 3 is how much? 9. So it will increase how many times? 9 times. Always you have to remember, what is the relationship between gravitational force and masses of the body? Directly proportional. And the relation between gravitational force and distance? Inversely proportional. You concept must be clear. Okay? Next one. It is coming slowly. It has already seen. What happened? Wait. One diagram was coming, you just moved fast. How many diagrams are there? Now finished.
One diagram is there.
One diagram about those
That
two
one
bodies
was-
only. Only that much. Only diagram is there.
Yes.
Other nothing, right?
What nothing?
No, only. What to do?
There
That-
are more questions, sir.
Still some question left.
Yes, there are two more questions left, sir.
I think this is the one. This is
Yes, this is one diagram.
Kim.
Not him, sir. This is one.
Your taka became taka. Okay, this is
Normal condition of that.
oh.
The gravitational force between two bodies if the mass of each is double and the distance between them is half. So with calculations,
Okay, see?
if the mass of each body is double and distance between them is half, then the force between them will be 9f4. Suppose the mass of the bodies A and I are respectively, and the distance between their center is
Hello,
d. Then the force of the gravitational between them is given by F is equals to g m1 into m2 by d square. According to the statement, the distance between the center of the two bodies is doubled, keeping the mass of them constant. That is, the distance between them, the distance between the center of the body is made to d. F1 is equals to g m1 into m2 by 2d square, or F1 is equals to 1 by 4 g m1 into m2 by d square. This is equation 2. From equation 1 and equation 2, F1 is equals to 4f. Hence, the force of a gravitation between two bodies will be decreased by 4 times. So the distance between them, between the center of the body is double. Thus, gravitational force between two bodies is inversely proportional to the square of the distance between the centers of the bodies. That is, F is inversely proportional to 1 by d square. In the formula, G is equals to G m times m by r square. What do G m and I stand for? Prove that G is inversely proportional to r square. In the formula, G is equals to G times m by r square. G is the gravitational constant, m is the mass of the earth, r is the radius of the earth, and m is the mass of another object near the surface of the earth. So g and radius of the earth, I dot it. From the universal law of gravitation, we know that F is equals to G times m into y, my into m2d square. If a body having mass m is kept on the surface of the earth, having mass m, the distance between the center of the bodies can be considered as equal now to the radius of the earth, that is d is equals to r. F is equals to G times m into m r square. We also have that F is equals to ma, second law of motions, and F is equals to m times z, that's the second equation. From equation 1 and equation 2, mg is equals to g m into m r square, and g is equals to m r square. For the earth, both the values of g and m are constant. Thus, g is inversely proportional to the square of the radius of the earth. So this much.
That much?
Yes.
Okay. Thank you very much. So, here was one question, like this type of question can be asked. This is quite easy. In the formula, G equals to Gm by R square. What does Gm are? Capital G is universal gravitational constant. What is capital M? Mass of heavenly body. What is R? Radius of heavenly body. What is small g?
Small g. Acceleration due to gravity.
Acceleration due to gravity. Acceleration due to gravity. One question was here. What change will be there if both mass and distance are changed? Then we can do one example. Suppose here are two bodies. How many bodies are here? So mass of first body m1, m2. Distance between them is how much? D. Force of attraction is how much? F. Isn't it? But in second case, mass of each body is, this is 3m1, this is 2m2. Distance is became d by 2. Children, listen, hey. This is the condition. What will be the change in force of gravitation when mass of each body, mass of the one body is triple, another body is double, and distance between them is half. At that time, what to write? So consider two bodies, m1 and m2, lie at a distance of d, and we know that F equals to, what is the formula?
F is equals to
G m1 m2 by d square. This is first equation.
Yes.
F equals to G m1 m2 by d square. Now, what does the question say? Question says
The first.
m new mass will be how much?
So
3m1. m1 new. m2 new, it becomes
2m.
2m2. Then new. Then F new equals to, oh, d. D new is how much?
So d is
D by 2. F new equals to G m1 new, m2 new I just said, by d new square. Now we can find out G m1 new is how much? 3m1. m1 new is how much? 3m1. m2 new is
So 2m.
2m2. Distance new is
So d by 2.
d by 2 square. Now G 3 to is how much?
6.
6G m1 m2 by d by 2 square means d square by 4. 4 goes up. 24G m1 m2 by d square.
24.
But
Yes, F, sir.
24 F. How many times the gravitational force increases? 24 times it increases. Because mass also increases and distance is decreases. isn't it? In that way, you have to do well. So this is the end of today's presentation. Remaining presentators will present tomorrow. Who are going to present tomorrow? Lamsal, Simres, Sarnia. 3 are left, right? That their work will be done. Now, for the day after tomorrow. Day after tomorrow means
This Friday,
Thursday, right? First Thursday's work, I will just give you from here. Right? For Thursday, now from where will it given? It will be given from new chapter. Which one? Please stand up. Pressure, definitely.
Yes.
So from pressure, they are going to present. And at first, we are going to present.
Ritika.
Ritika's first one is page number 176, 177, 178. 176, 177, 178. Okay, Ritika. Then who is after Ritika? Luniba. 179, 180, 181. 178, no, 79, 80, 81. And 3 candidates. After it, Luniba was done. Nirisa. Nirisa 182, 183, 184. So one up to 184 will be discussing. Okay. Now you will take out your books, copies, and start doing the work quickly.